Today we're looking at higher order derivatives and the product rule. In the next video, you'll look at quotient rule. All right, so there's a lot of different ways to write a derivative. So you've seen y prime, f prime of x, f prime, dy dx, or d dx of f of x, or d dx of the function. So a second derivative would be like y double prime, y triple prime, y to the fourth, y, the nth derivative of y, okay? We have f prime of x, and then f double prime of x, f triple prime of x, the nth derivative of f of x, okay? Oops, I missed one. The fourth derivative of f of x, and then the nth derivative of f of x. All right, dy dx is a little different. So it's really, this is d dx of y, but we write it as dy dx for short. So when we take the second derivative, it's d squared dx squared, and really it's like that. But again, for shorthand, we do dx squared of y, so the y goes on top. The third derivative with respect to x, okay? The fourth derivative with respect to x, 4 times of y, okay? The nth derivative of y with respect to x, okay? Same here, we do d squared with respect to x squared of f of x, d cubed with dx cubed of f of x, d to the fourth derivative of f of x, and the nth derivative of f of x. Okay, those need to be brackets. There we go. All right, so those are all different ways to write our higher order derivatives. So higher order derivatives, honestly, we can just keep taking the derivative of a function. My iPad's a little laggy, it's catching up. Okay, so I am going to take I'm going to find the third derivative since there's 3 tick marks. So I'm going to find the third derivative, we have to find the first derivative, the second derivative, and the third derivative. So the first derivative would be f prime of x is equal to, I'm going to use the power rule, 3 times x squared. Then I take a second derivative, f double prime of x is equal to 3 times 2 is 6, x to the first power, because we're reducing the 2 by 1. Finally, we can take the third derivative of f, and so there's an invisible 1. We get 1 times 6 is 6. Oh, and x to the 0 power, which just gives us 1. So it's just 6. All right, let's do the next. So we have the derivative is 5x to the fourth power minus 3. And I know that because this notation tells me that's the derivative. So I want to take the second derivative. So we write that d, the second derivative, like that, okay, is equal to, I'm going to use the power rule twice because I have 2 terms. So 4 times 5 is 20, x to the third power, minus 1 times 3 is 3, x to the 0 power, which is just 1. Okay, I'm going to take the third derivative, and that is going to be 3 times 20 is 60, x squared. The constant is 3, so I don't have plus 0. Fourth derivative, and you have to write the notation. If you don't write the notation, we don't know what you're doing. Okay. 2 times 60 is 120, x to the first power, and that's it. That's all we're doing. Fourth derivative there. I could keep going until I have a 0, basically. All right, last one. We're going to find the fourth derivative of y. So I'm going to do y prime is equal to, what is the derivative of sine? Remember, I use cosine, sine, negative cosine, negative cosine? Negative sine, sorry. So I'm starting with sine. So I'm going to go down to cosine. And then y double prime, the derivative of cosine is negative sine x. Y triple prime, the derivative of negative sine is negative cosine x. And the fourth derivative is back to positive sine. We're not really that surprised. We took the derivative of a trig of sine or cosine 4 times, so that's going to just complete our little derivative loop. All right. So acceleration is the derivative of velocity and the second derivative of position. So remember we started with position yesterday, and then when I take a derivative of position, I get velocity. When I take the derivative of velocity, I get acceleration. Had to do a spelling check just there. Okay, so if we call the position f of x, the derivative of f of x will be f prime of x. That describes velocity. F double prime of x is acceleration. Another really common notation for position, velocity, and acceleration is x of t is position, or we saw it as s of t. These are very common. Okay, we can call the derivative of x of t v of t, so we don't have to say v prime of t. We can just say v of, or x prime of t. We can just say v of t, and we'll know that it's velocity. Okay. Again, I don't have to say x double prime of t. I can just say that the name of the acceleration of, function is a of t. All right, so we're going to the position, do this example. So the position of a particle is given by the equation x of t is equal to 4t cubed minus 3t squared plus 5t minus 1. Find the acceleration of the particle when t is equal to 3. So I have position. How do I get down to acceleration? Well, we take the double derivative. So I'm going to say x prime of t, which we don't usually say, we call that v of t, is equal to 3 times 4 is 12 t squared, and then negative 3 times 2 is minus 6t, and reduce the power by 1. And then 5t times 1 would give me plus 5t to the 0 power, and then the negative 1 is a constant. All right, so that is velocity. I don't care about the time yet because I need to get the acceleration function. So how do I get the acceleration function? I take the double derivative of x of t, which was also equal to a of t, the acceleration function. All right, take the derivative. 24t minus 6. And now I know the equation for acceleration for my whole entire function. So when are we evaluating the acceleration? At t equals 3. So I'm going to go ahead and plug that in. A of 3 is equal to 24 times 3 minus 6, which gives us 66 unit. There were no units, so we don't have to worry about that. All right, so the acceleration at time 3 is equal to 66. All right, we're going to do the next one. So I've seen these on the AP test before. They give you a table, and we have to approximate the value of acceleration. So the table describes the velocity of a particle, so how fast the particle is moving. And we need to say what is the acceleration, so how fast is it speeding up, okay, or down. So right now we want to find the approximate when the particle is at time 5. So when can we take, which values would give us the best estimate of our derivative? Can we just take a derivative? Do we have one point that I can like evaluate at? No, we have a table. So the best place for us to find the average rate of change would be at the 2 points closest to 5. Okay, so I am going to do acceleration is the slope of velocity. So we got to take the slope. So we're going to take the average rate of change between the velocity at time 6 minus the velocity of time 4 over the difference in time, 6 over 4. I get 16 minus 10 over 2, which is 16 over 10 is 6 over 2 gives me 3. And then what are our units here? So acceleration is meters per second for time squared. All right, next up is product rule. So product rule is just a different derivative strategy. So it's when we have two functions that are being multiplied together, and what we do is we take the derivative of the left and multiply it by the regular function on the right. Then we add the regular function on the left times the derivative of the right. So one way to remember this is the right function, okay, like g, see, times the derivative of the left plus the regular left function times the derivative of the right. So we say right d left plus left d right. Another way to remember this, I like to see this as if I have the derivative of u times v, that's just a bracket, u times v, then what I do is and u is one function and v is another, I just take the derivative of u times plain v plus the derivative of plus u, plain u, times the derivative of v. Okay? All right, so we're going to practice here. We're going to pick out our two functions that are being multiplied together. I have x squared and 2x minus 2. So the left is x squared, the right is 2x minus 2. So we're going to take the derivative of each. You can set it up on the side. I'm going to call u is equal to x squared and v is equal to 2x minus 2. You may have to do this work on the side and you may not. It's fine, okay? So the derivative of u with respect to x is 2x. And then v, the derivative of v with the respect to x just means that the variable is x, okay, is 2. So this just helps me set up. I can say I'm going to take the derivative, plain u, and multiply it, the derivative of u and multiply it by v. So I'm going to take u and multiply it by v. So I have 2x times 2x minus 2 plus on the derivative of v times plain u. So 2 times x squared, giving me 4x squared minus 4x plus 2x, which is f prime of x is equal to 6x squared minus 4x. It's just kind of a lot of work to organize, okay? All right, you might be able to do this one in your head. That's okay. Let's pick out our left and our right. Our left is 3x squared. Our right is sine x. So u is equal to 3x cubed. Sorry, I said that wrong. And v is equal to sine x. Okay, the derivative of u with respect to x is 6, no, that's a 3, 9, this is what happens when you don't have neat work, 9x squared. Okay, v's derivative, dv dx, is equal to the cosine of x. All right, we multiply, so 9x squared times the sine of x plus, I'm going to put 3x squared first times the cosine of x. And that's it. Did I do that right? 3x cubed. Why? Why do I keep doing that? Okay, number 3, definitely try this on your own first. The left is x cubed minus 4 times the right factor, 2x minus 3. So I get y, I'm going to do this one in my head. You ready for it? This is u, this is v. All right, so I take the derivative of u, which is 2x, nope, 3x squared times v, which is 2 minus 3x. And then I'm going to add the derivative of v, which is negative 3 times the times plain u, x cubed minus 4. Okay? My face is in the way again. All right, so we're going to simplify. Y is equal to 6x squared minus 9x cubed minus 3x cubed plus 12. Combine my like terms. Y prime, don't forget those primes, is equal to negative 12x cubed plus 6x squared plus 12. All right, last part, I think. So product rule can be generalized. Say if I had three factors that I needed to multiply. This is, I can take the derivative of 3 factors by taking the derivative, multiplying f of x times g of x times h prime of x plus f of x times g prime of x times h of x plus the last one, f prime of x times g of x times h of x. All right, I think we're going to have to do that in the warm-up. All right, we need to find the position, we have the position, and it's defined by t squared minus 4t times cosine t. And we need to find the acceleration of the particle. So this is x of t. So what we want to do is find acceleration, which means we have to take the second derivative of the position. So we go, the velocity of t is equal to, the u is going to be t squared minus 4t, and the v, which I just made those look exactly the same, is equal to the cosine of t. Okay, take the derivative of each, du dt, because the variable is t in this case, is 2t minus 4, and v dv dt is equal to the negative sine of t. So we go cosine t times, so v times du is cosine t, I'm going to write it the other way, and I'm going to write it down here because I can see I'm going to run out of space. So 2t minus 4 times the cosine of t plus I have u times dv, so t squared minus 4t times negative sine of t. I'm going to rewrite this so that the negative is in the middle. Okay, so actually it doesn't matter. I'm just going to leave it. All right, so next I need to find the acceleration. So that's the double derivative. So I have to take the product rule twice. The left side, right side, left side, right side. So VU2 and V2. V2 is going to be cosine t, and U2 is going to be 2t minus 4. And then on the right, U3 is equal to t squared minus 4t, and V3 is going to be equal to negative sine of t. Okay, so du2 over dt is equal to 2, just plain 2. And V2 dv1, over dt is equal to, the derivative of cosine is negative sine t. Now we do the same for u3. du3 is going to be 2t minus 4, and dv3 over dt is equal to, the derivative of negative sine is negative cosine t, and I just used, again, sine, cosine, negative, cosine. So negative sine, the derivative of negative sine would be negative cosine. All right, so now that we have that all set up, we can take the derivative, giving us the acceleration of t would be, all right, so I'm going to do v times du, so 2 times the cosine of t, plus u times dv, so 2t minus 4 times negative sine of t, all right, plus, because I have a plus in the middle here, I have u times du, which is 2t minus 4 times negative sine, 2t minus 4 times negative sine t. Does that look familiar? Yes. Okay. Next up is u times dv, which is t squared minus 4t times negative cosine of t. All right, last step is to, since I have my acceleration equation now, I need to substitute in the time. So I need the acceleration at time pi over 2. And I remember from trig that pi over 2, the coordinate is 0, 1. So anything with a cosine is going to be 0, and anything with a sine is going to be 1. So I'm going to go ahead and plug this in. Cosine of pi over 2 plus 2 times pi over 2 minus 4 times negative sine of pi over 2 plus 2 times pi over 2 minus 4 times negative sine of pi over 2 plus pi over 2 squared, all squared, minus 4 times pi over 2 times the negative cosine of pi over 2, which I don't really care about because it's going to cancel. Okay, so anything with a cosine pi over 2 cancels to become a 0, so these two factors cancel. Woo! Okay, and then anything with a sine of pi over 2 becomes a 1, so this is actually times negative 1. It's actually times negative 1. Okay, so I get the acceleration of pi over 2 is equal to negative, my 2's cancel, pi minus 4, and then my negative times, again, my 2's cancel, giving me pi minus 4. All right, we're almost done. Let's distribute. So negative pi plus 4 minus pi plus 4 gives us an acceleration at pi over 2 of negative 2 pi plus 8. And our units were not defined, so we're good. And that is it.